solve sine squared x minus 3 sine x equals 4. So just like yesterday, what is the overwhelming part of this right now? Sine x. So can I not replace it with a different variable and then not have it be overwhelming and have grade 11 quadratics? Yes, so let's do that. So I'm going to do let m equal sine x. So then I'm going to get m squared minus 3m equals 4. And now I'm back to grade 11. We agree? What do we have to do when we have a quadratic? What's our first step always? Set equal to 0. So we're going to get m squared minus 3m minus 4 equals 0. And then this factors to m what? M minus 4 and m plus 1. So that's grade 10. Then grade 11 said, okay, we just set these equal to 0, and we solve for them. So these are the factors, right? We're finding the roots. So m minus 4 equals 0, m plus 1 equals 0, m equals 4, m equals negative 1. And then a lot of people will box this and move on. Problem is, that's a grade 11 question, and we're in trig, and there's no trig involved yet. So what do we still have to do now? Sub back in the sine x. So we get sine x equals 4, and sine x equals negative 1. So you know how we solved yesterday? We're going to now do trinomials. That'll bust us down to 2 single signs where we have to solve like yesterday. Okay? So the first thing we're going to do is always plug them into our calculator and know where we're going to go. So we'll do this one first, this side first. So this is going to be my y1, and this is going to be my y2. And I have my other computer up so that I could finally use a calculator again today, and then it just kept freezing, so once again, no calculator. So can you please type it in, y1, y2? This one's actually quite easy for me to sketch. So it's going to look like this. Remember, your y max has to be at least 4 because it's going to draw a horizontal line at 4. And we'll just do it in degree mode today. Talk about radian mode tomorrow. What's the problem? Where do these intersect? They don't. So just so you know, chapter 5 we haven't done yet. I do it after. The only reason why you would do it before is to let you know what an actual sine graph looks like. A sine graph, a basic sine graph, maxes out at 1 and mins out at negative 1 because that's what the unit circle does, correct? Your unit circle sine x maxed out at 1 and mins out at negative 1. It's the y values. We agree? So if ever you have a sine x equal to anything greater than 1 or less than negative 1, you're going to get no solution because your sine x graph is just going to nicely sit here and go along for the ride, and then your 4 is going to go above. Okay? So this one gets no solution. This one's the best. There's no work. And some people say, well, they're extraneous solutions. No, extraneous means I got a solution, I plugged it in, it didn't work. No solution means there's absolutely no way these two things cross. Okay? Now let's type in our other one. So now we're going to change to that negative 1 instead of 4. And I want the answers between 0 and 360. That's the domain we're going to sit in today. 0 degrees and 360 degrees. Equal to them. So this is the same as me writing 0 degrees is less than or equal to x is less than or equal to 360 degrees. So make sure to change your window from 0 to 360. Your x minimum is 0, your x maximum is 360. Everyone should be typing into their calculators. So now you have a line at -1, right? Find out where it intersects. Second trace 5, enter, enter, enter. Make sure you're in degree mode, or your graph isn't showing up. And you should only have a graph that looks like this. Correct? On your screen? Incorrect that I have this. Oh my goodness. Your screen should look like that, right? Where did it intersect at? 270. So we know that's where we're going for, 270 degrees. Do we actually need our calculator to do this? We can go x equals sine -1 of 1. Just to get the reference x. What does that give us? 90. Okay, this one's a little bit different. Our reference x equals 90 degrees. That means this is landing on an arm. So do I need to really get the reference angle for it? I'm going to look for when this is, we don't need to do this, do we? I'm going to look for when sine x equals -1 on my unit circle. Where does sine x equal -1 on my unit circle? At 270 degrees. So yes, you can do the reference angle stuff, you can, but if it's something that's directly off the unit circle, just go find it. Just do a sketch, plot the dot, write the answer. So this could be a numeric response question. It only gave me one answer, even though it looks like it should give me a whole bunch. Now, was that the actual question though? Was the question sine x equals -1? No, we should have typed the original into our calculator first. So this should be what we typed in. y1, y2. How do I type in sine squared x? Because I can't type it in like that. Sine x in brackets, all squared, minus 3 sine x. So now type that in, y1, y2. You type it in y1, y2. There should be one intersection. Second trace 5. Enter, enter, enter. Did you get 270? I don't remember to record. This is our only solution, and if we plugged it into here, this left side is going to equal 4. Correct? If I take 270 and I plug it back in, left side will be 4 because right side is 4. And they'll match and we'll know we're right. We're just solving trig instead of solving like a quadratic. Okay? So what I always do personally is I will always y1, y2, the original equation, get my answers so I know where I'm going, so I feel confident when I get there. Yeah? Instead of working backwards and hoping it's right at the end, you're like slowly typing it in and hoping you're okay. Now sometimes it's calculator error typing, so you have to watch yourself as well. All right. I want you guys to try this one. I want you to type in your calculator for now. We're going to talk about this one, because this one goes downhill real quick. In the very first step of solving this, I can tell if people are going to get full marks or no marks. In the very first step. So we're going to type it into our calculator, hopefully. We remember to do that, and then it'll catch that we are missing things. So go bracket tan x squared. And on the other side, you have tan x. I really wish my real computer was working. I had a calculator on it so I could show this, but no, it decided to freeze. So the first solution I'm getting is at what? X equals is 0 one of them? And then looks like maybe 45. Then 180. Yep. And then 225. And then let's say 360. This looks like where we're going. Okay? Now, I would star this question. It's done terribly. It's a really easy question. It's done terribly because the first step, you guys will leave things off right away. So my first question is tan squared x equals tan x. And like I said, sometimes the tan x is the part that is actually overwhelming, right? So we can let m equal tan x. So we get m squared equals m. What is our rule for quadratics? Not this, all quadratics. Move everything to one side and set equal to 0. Have we ever done that by dividing something off and getting rid of half your solutions? No. A whole bunch of you will divide by m. Make it equal to 1. You've gotten rid of half of your solutions. Do not do that. The rule when you have a quadratic is everything moves to one side, set equal to 0. And you move everything to one side by addition or subtraction. Right? So I am not going to divide that over. I'm not going to divide a tan x from both sides. I'm going to subtract m over. So I'm going to get m squared minus m equals 0. And then people get stuck if they get to this step sometime. What do we have to do? What could we do? Yeah. Take out a GCF of m, take that m out. So we're going to get, my recording. Yep. M, and then we're going to be left with m minus 1 equals 0. Do you see that if you divide that m over, the m equals 0 solution's gone? You rid of half of your solution. Right? We don't want that. No division when it's quadratic. So always move everything to one side, set equal to 0. Move everything to one side, set equal to 0. Right? Whenever we have a squared, we can always do that. Whenever we have a squared term, everything to one side, set equal to 0. Then we split these. We get m equals 0, and we get m minus 1 equals 0. So m equals 1. Okay, what's m the same as? Tan x. Guess what? Tan x equals 0 is on our unit circle. And tan x equals 1 is on our unit circle. Tan is what divided by what? Y over x or sine over cos, right? On our formula sheet it tells us that. So it's sine over cos. How's the only way I can get it to be equal to 0? Which one of these has to be 0? Sine or cos? Sine. Because if cos is 0, it's undefined. Correct? Sine, so whenever sine is 0 and cos is any number, I'm going to get 0. We agree? So where on our unit circle is sine equal to 0? Where is y equal to 0? Zero, 180, 360. Now that's when you have to watch your restricted domain. Sometimes the restricted domain has square brackets around it, and sometimes the restricted domain has round brackets. Or one of them's round and one of them's square, correct? So because these are both square, 0 and 360 are in. If this was round, the 0 was round, then only 360 would count. If the 360 was round, only 0 would count. If they were both round, only 180 would count. Yeah? So you have to watch those square round brackets. Okay, cool. So we know that x equals 0, 180, 360. This is making me happy because 0, 180, and 360. Check, check, check. Right? You find the answers before, you can start feeling confident that you're actually going on the right path. If your answers don't match any of those, be like, because sometimes your algebra is right and you just put it into your graph with a plus sign or a minus sign, or you didn't square it right or something like that. Good to watch that. Okay, where does tan x equal 1? When sine and cos are the same, correct? So when sine x and cos x are the same number. So when this number is the same as this number, I get 1. Do we agree? So where are sine and cos the same numbers on your unit circle? Yeah. 45 and 225. At 45, we have root 2 over 2, root 2 over 2. So when I divide those, I'm going to get 1. At 225, I have negative root 2 over 2 divided by negative root 2 over 2. It'll be this one divided by that one, which is also 1. What happens to the other 245s? You're in negative 1, because one's positive, one's negative, right? So this is 45 degrees, and this is 225. So those are both right. And we can actually just do this. Hey, I have the algebra for it. I can now box my answer. Even though I got that answer from the calculator, does anyone know that you got it from the calculator? You showed literal algebra, right? You confirmed that answer. Box it. Know what I'm saying? Yeah. I like doing the little graphs so that it shows you know what you're doing. No. If it says determine and you don't show anything mathematically, you could lose marks. So that's why I always draw the graphs, just to show them where it's hitting. So they know I didn't just use my calculator, tan x and tan x equals 1 and got answers. I actually know why I got answers. All right, so to your notes. I feel like to the Batmobile. To your notes. All right. So that is if I just give you all tans together, or all sines together, or all coses together, correct? Then I have to move everything to one side and can replace the cos, the sine, and the tan, and I can solve it. Using grade 11 math. And a little bit from yes. Yeah? What's going to happen here, and we'll come back to this page in a second. What's going to happen here is I'm going to have mixed things. Look, I'm going to have a cos squared and mixed in with a sine. I'm going to have a sine squared mixed in with a cos. I'm going to have double angles, so cos 2x. I'm going to have sine 2x. So those have to get out of my life, because as long as I have all sines, all coses, all tans, I can do math, right? I have this cos 2x, that ain't squared. Don't be like, oh, Mrs. Lepp, you forgot to put the 2 higher. I got you. And then you guys do this. No, I didn't. It's supposed to be a 2. Just leave it where it is, okay? That just means it needs to be replaced. So that's why, bless you, we're on our first page. We have all of these formulas. So the formulas we're going to look at today are the Pythagorean theorem identity formulas and the double angle identity formulas down here. Okay, they're all given to you. The catch with a formula, though, is, and that's what everyone forgets, the catch with a formula is you can rearrange it. Formulas are not stagnant. It doesn't have to say sine squared plus cos squared equals 1. Okay? Now, the reason why this formula exists is this is x squared, this is y squared, and it equals 1. We agree? It's just the unit circle formula with sines and coses in instead of x's and y's. All right? If we use different like sines and coses and replace it in here with tans and secants where they may be, we can also get these other two Pythagorean theorem identities out from that by just replacing them with like 1 over tans. What I want you to do is okay, sine squared plus cos squared equals 1, cool. How else could I rearrange this? Well, I could get sine squared by itself. So sine squared x could equal what? 1 minus cos squared. So if ever I have a sine squared, I can rip it off my page, toss it out, and replace it with 1 minus cos squared. Do you agree? They're the same, equivalent. Sine squared equals 1 minus cos squared. If I ever have a sine squared, I take it off my page, toss it, and replace it with a 1 minus cos squared. Do you agree? Okay, how else could I rearrange it? What if I wanted cos squared by itself? Cos squared x. What would it equal? 1 minus sine squared x. So if I remember cos squared sitting by itself, I need it to go away, I can replace it with a 1 minus sine squared. A sine squared I can replace with 1 minus cos squared. And if I had sine squared plus cos squared anywhere, I could just replace it with the number 1. It's the same thing. Okay? Now, why the heck would I ever want to replace a sine squared? Well, I might want to replace a sine squared if it's sitting with a cos x in an equation so that I have all coses now instead of sines, right? That's why you replace, because ultimately we're trying to get an equation that has all of the same things. Okay? Then we have the same thing here. I can solve tan by itself. So if I have a secant squared, I can replace it with 1 plus tan. If I have tan squared x by itself, that is not tan, that's cos squared. I could replace it with secant squared x minus 1.
Please excuse the interruption.
Okay, and then if we have 1, we could replace a 1 with secant squared x minus tan squared x, which doesn't really happen very often. The 1s are often replaced with like the sine squared x plus cos squared x, but it could happen. And then same thing here, 1 plus cotan squared x equals cosecant. I could do cotan squared x, I could replace with cosecant squared x minus 1. And then if I had a 1, I could replace it with cosecant squared x minus cotan squared x. It's often not used as well. So we're often using these ones. We're often replacing a sine squared x with a 1 minus cos squared, or cos squared with a 1 minus sine squared, or tan squared with a secant squared x minus 1, or secant squared x with a 1 plus tan. So we're replacing it the reason why we're replacing it is to get all the same things together. Does that make sense? So the squareds can get replaced. Like cos x can never become sine x. But cos squared x can become 1 minus sine squared x. And that's where we can get the squared and the same trig ratio. So we're going to leave double angle identities until we get to the double angle identity questions, which is example 2. We're going to go to example 1 right now. So next page. So on a test, I get people looking at this and they say, oh, and they just solve it like normal and somehow replace the cos squared with a sine squared and like, she must have typed it wrong. She didn't type it wrong, she's me. I need either all coses or all sines. We agree? Currently I have a cos squared and a sine. Can I, So can sine x ever become cos x? A single sine. Is there a formula on your formula sheet where a single sine can become a cos? No. So we're never replacing the single sine. Do we agree? Is there anything on our formula sheet that we could replace I'm going to just replace the cos squared. You could replace 1 minus cos squared if you really want to. Let's do that. What's 1 minus cos squared the same as on your little sheet? Sine squared. You're welcome. That's the new thing. That's it. Now they're all what? Sines. So we're back to what we just did before. Nothing crazy, right? So we have sine squared x minus 3 sine x plus 2 equals 0, because our first step is to always get it equal to 0 whenever we have a squared term. Correct? We don't overthink it. Then you can either factor and keep signs in there if you so choose, or you can go let m equal sine x, which is what I'm going to do. So I get m squared minus 3m plus 2 equals 0. And then what do I get for factors? So I get m equals 2 and m equals 1. Then I replace it back. Sine x equals 2. Sine x equals 1. What is a hunter's moon? I don't know. All right. Just touch that. Okay, where does sine x equal 2? Trick question. It doesn't. Remember the sine x graph? It's just basic sine x. Max is at what? 1. And then I draw the line at 2. Do they ever cross? No. So what does this one result in? No solution. It means 1 couldn't exist. And remember, extraneous means I got a solution, it doesn't work. So this is a no solution. Okay, where does sine x equal 1? I need a circle. 90. Where y equals 1. This is the only place. Some people will give me 270 as an answer. But 270 is where y equals what? Negative 1, so it's no good. So x equals 90. Okay, I box it, I move on. True statement? Why? It's in radians. X equals pi over 2. Box it, move on. Right? Can we do the question in degrees and convert to radians? Absolutely, we just need to have radians in here as our answer. Now, what would I hazard you to do instead of what we just did? What should we have done first? Put it in our calculator, y1, y2. Okay? y1, y2. Let's go. So y1 is going to be 1 minus cos x all squared. And y2 is going to be 3 sine x minus 2. Find out where they intersect. You could do the range between 0 and 2 pi. You'd have to make sure your calculator's in what mode then? Radian, right? Or you could just leave it in degree and convert at the end. That's what most people will choose. Did everyone get his work? Did you get 90? Get 90? If you get 90, move on to the next one. I would type it in first to see where you need to go though, right? Try that out. Any solving question on the diploma, I would personally, any solving, no matter if it's in polynomials or here or logs or exponentials, I would y1, y2 and find out where I need to go every single time. For you, and you or me, I would see the 1 minus sine squared as a replacement with cos squared, correct? But what if there isn't a 1 there and you have to replace? Well, you can just replace the sine squared, and I want to show you how that happens. Okay? We're going to end up at the same step. In about 2 steps, we're going to end up at the same spot. Okay? So we have 2 cos x plus 1 minus, and now I'm replacing the sine squared, yes? And when I replace anything with one term with two terms, I have to make sure I put it in brackets. So I'm not going to replace the 1 minus sine squared this time. I'm just going to replace the sine squared to prove to you that I can just do that. So if we look on that previous page, and I'm just replacing sine squared, I'm going to replace it with 1 minus cos squared. Do you agree? Make sure you're not on your phones. So we're going to get 1 minus cos squared x. I love how a few of you just threw up calculators like it's not me. It's not me. Beautiful check. All right. So do you see how I have to put it in brackets if I go that route? Because what's in front of it? I'm not replacing negative sine squared x. I'm just replacing the sine squared x, yes? So this negative sign has to go through. So then I get 2 cos x plus 1 minus 1, which cancels, minus cos squared x equals 3. And do you see I'm in the same spot as you were if you replaced the 1 minus sine squared x with negative cos squared x? It's the same thing. I mean positive. Woo, distribute and then don't distribute. That's what I just told you to do, and then do it. Negative 1 plus, right? So we end up in the same boat. We'll both end up with that cos squared x. I personally will do 1 minus sine squared x and replace the cos squared x because it's faster and it's less of an oopsie. But you don't always get that option. Okay. Does that make sense? All right. So then we have 2. I'm going to go in order. Cos squared x plus 2 cos x minus 3 equals 0. Let m equal cos x. So I get m squared plus 2m minus 3 equals 0. M minus 3 plus 3 and m minus 1. So m equals negative 3. So these are the best because half your solutions seem to be going away. That is not always how it goes. This is like you throw yourself a little party when this happens. Often we end up with decomp. You get like m equals a half and m equals root 3 over 2, and then you get your solutions, you get like 4 solutions off your unit circle, right? So this one is cos x. Now, if it is anything but cos x or sin x, you can't use that rule. You know how I said sin x maxes out at 1 and mins out at negative 1? So does cos. Cos maxes out at 1 and mins out at negative 1 because it's the x, it's unit circle, yeah? But tan, secant, cosecant, and cotan keep going on for forever. Well, for a large portion for cosecant and secant. So those ones you can't say no solution to. Only ones that if it's greater than 1 or less than negative 1 that result in no solution is when it's cos x by itself and sin x by itself. Okay?
Please excuse the interruption. We are, thank you.
Okay, so the cos x graph actually looks like this. This is 1, this is negative 1, and then negative 3 is like this, right? So no solution. But it only works with sine and coses. This one is cos x equals 1. Where does cos x equal 1? Where does x equal 1? 0 and 360 or 0 and 2 pi. Then I have to go back and look. Which one's included? 0, which one's not? 2 pi. Yeah? Okay. I'm going to give you 3 questions you have to do on a separate sheet of paper. By 3, I mean 2. Do I have to give you the solutions to know if you're right? No, you can check with your calculator. You can also check your solutions into left side, right side, see if they equal. Yes, there's 2 ways to verify these. We're going to replace the cos squared x only, correct? So what are we going to have to remember to do with that 2 in front? You have to do brackets, 1 minus sine squared, and distribute the 2 through. Yes? Because we're just replacing the cos squared. We always replace just the sine squared or the cos squared, so that's 1. These are your 2 questions. This one we have to replace that cos squared, so that's all sines. This one is coses, correct? But you have to stop yourself from trying to divide it over. What are we going to do for our first step? Get it equal to 0 by using addition or subtraction. Yes? Every single time. So this one is done terribly. It's not hard, it's just done terribly. So we have to remember, add or subtract it over to get it equal to 0. Never division. Okay? You get rid of half your solution.